Okay, so we talked about what matter was in the last video. I got to it eventually, yes. If you tuned out early, just go back and look again. So, you know, it's anything with mass that takes up space. So it's just about everything. Like this table, that's made of matter. This DocuCam, matter. This marker, matter. This tuk-tuk right here doesn't matter, but it's made of matter. Alright, so energy. So remember, the study of chemistry was, you know, the study of matter and its changes. Well, energy is what is associated with changes in matter. So energy changes matter. So for example, you know, if we have something like ice, if we add energy to it, heat is a form of energy. If we add heat to ice, it becomes liquid water. So for example, adding heat, which is energy, to ice melts it. It becomes liquid water. So you can think of it as the ice is absorbing heat, or we're pushing heat into the ice, however you want. It's just a perspective thing, you know? Is the car moving or is the highway moving? I mean, there's a, you know, a sensible answer, but there's a philosophical question in there that you can have fun with. And that's what we're doing here. Is, you know, it's so anything that causes changes in matter is energy. Now there's two types of energy. Alright. And we're going to circle back to energy more later as well, and relate it to like chemical reactions and stuff, but that's not till much later. And so the first one is kinetic energy. So this is like the energy of motion, or, you know, change happening. So for example, you know, heat is a form of kinetic energy. A moving car is a form of kinetic energy. What else have we got? You know, electricity traveling through a wire is a form of kinetic energy, on and on and on. And so this is like energy that's being used. You know, you're moving, that's, you know, and like heat is molecules moving, by the way. So like if you touch a hot surface and you get burned, what's happening is those molecules are moving, and then you touch it, and then the molecules in your hand start to move, and they'll start to, like, you know, fall apart, like on the molecular level, and that's what a burn is. It's literally like you're being shaken apart atomically. Like that's what heat is. So the other form of energy is potential energy. Some form, you know, some energy it reaches its potential, and some of it does not, right? Yeah, just like people. I have a ton of potential energy. Haven't really converted it all into kinetic energy in my life, but whatever. Okay, so all right, it's getting late in the day if I'm making that joke. But anyway, no one laughed at that, but it's okay because I've seen enough classrooms not laugh at it to know. Alright, so potential energy, this is like stored energy. Okay? And the reason we call it potential energy is because it has the potential to cause change. It's not causing change, it's not kinetic energy, but it can be unleashed to cause that change. So it can cause change, but isn't. So some examples of this, you know, like a charged battery has potential energy. And as you use that battery, it comes out in the form of kinetic energy. It generates electricity, you know, it releases electricity. So electrons move through a wire, that's movement, that's a kinetic energy. It makes light, is a form of kinetic energy. It can produce heat. Your phone can definitely get warm. Mine has started doing this thing where it just starts like, has like a stuck button when I charge it. And so it's on the charger, just like bup, 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 bup. I wake up in the morning, it's got like 25% battery life despite being on the charger, and it is red hot. I think Samsung might have just been trying to burn my house down. I don't know. but it's really annoying. And so it's using a ton of kinetic energy. It's getting really hot. That's the moral of the story. So a charged battery, you know, water behind a dam. That's potential energy. We can release the water through the dam, generate electricity. The water moves. That's kinetic energy. Gasoline for a car. So the car moves. That's kinetic energy. Well, where's the potential energy that gets converted in that kinetic energy? Gasoline, unless you have one of those highfalutin electric cars, in which case it's a battery. But yeah, so it burns the gasoline, puts it through a chemical change, turns it into CO2 and water, and releases heat and kinetic energy. It moves the pistons in your engine, and that motion gets converted into motion at the wheels, and you go. So that's what happens. So that is another form of potential energy. So there's like a chemical potential energy as well in your gasoline for your car, and that's kind of something we'll talk about more later. But these are the types of energy, two major types. So there's kinetic and potential. Causing change can cause change, but it's being held back somehow. Those are the two. So this is like the ball rolling down the hill, and it's right at the tippy top. It hasn't gone one way or the other, but it could just go and it's gone, and then you have to run after it. And so energy is just, you know, anything that can cause change in matter, which is in my wheelhouse. By the definition of my field, I get to talk about energy. So that's the story on matter and energy, and we will come back to this more as well. So a lot of this introductory stuff, we kind of do an early introduction, and we talk about some more stuff, and then we circle back and we add more detail to these ideas. So it's kind of like a spiral staircase. We just kind of build up, 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 and then boom, before you know it, you're talking about cellular respiration and energy changes and chemical reactions and all kinds of stuff. So that's what we're building towards at the end of the class. So it just keeps going, going, going. Like we're going to do like some introductory stuff, and then we're going to go from like, oh, matter is stuff that takes up space, and then we're going to be like, here's atoms, and this is what they're made of, and then they become ions, and then they become compounds, and then they become organic compounds, and biomolecules, and it just gets bigger and bigger and bigger and bigger, and then we're talking about like reactions and all that stuff. So, you know, don't get behind, stay on top of things, because, you know, we go an inch deep and a mile wide, because we go through material that if you were a chemistry major, you take a year of Gen Chem, you take a year of organic chemistry, you take a year of biochemistry, and we condense all that down into, well, 8 weeks in the summer, or 10 weeks during fall, winter, and spring. So you want to understand that, you know, we're just cutting a path through the jungle here. So there's a whole lot of sights to see on the way, but I'll try to be very clear about what I expect you to know, and what it is just what we need to know to do the next thing, to do the next thing, to do the next thing. We just keep building, building, building. Alright, so on that note, we are going to talk about the structure of the atom next, and this will be kind of like when we really start getting specific and start talking about the pieces that we're going to build off of for a lot of the class coming up.